This is my atomic theory timeline project, and my teacher told me to make it creative, so I decided to build it all in Minecraft and go from there. So for this project, I had to find 20 people that contributed to the atomic theory, and also 20 events that happened in between all of their contributions to the atomic theory. So what I did is I built something representing their atomic theory, and then I also built something representing that timestamp period. So starting off in 400 BC is Democritus. He originally thought of the atom that we have today and kind of made a little thing. And our timeline event in between was when Sparta declares war against Persia from 400 to 300 BC. And I just made a little Spartan helmet. I don't know. I just threw this kind of stuff together. Next up, we have Aristotle in 330 BC. What he did is he disproved that earth, wind, and fire were the four major elements of the world that made up everything. And right here, I just have like a little statue of him. I really didn't know what to put for him, so I just made that. Next up, we have the birth and death of Jesus from 4 BC to 32 AD. Another timestamp, because it's such a big time jump from, what was it, 330 BC to like 1600 something. I added another little timestamp. Next up in 1662, we have Robert Boyle. He believed that everything was composed of tiny little particles known as atomism. He also referred to these particles not as atoms, but as corpuscles. I have no clue, but that's what he called them. And the timestamp that we have in between is America declaring its independence in 1776. Up next is Antony Lavoisier. I probably butchered that, but that's his name according to me. In 1789, what he said is that elements as chemicals could not be broken down into other substances, which we still do have today. So, good job, Antony. You were correct as of right now. In between Antony and the next scientist, we have the French Revolution, which was from 1789 to 1799. Now we have Joseph Proust in 1794, which said that a compound is always composed of the same proportions of elemental mass. So we have the same amount of gold here. They weigh the same on the scale that was thrown together in 2 minutes. What we have here is the Liberty of Congress, which was founded in 1800. Up next in 1803 is John Dalton. His role in the atomic theory is he kind of combined everyone else's little theories into his kind of own theory that had 5 main rules: that all matter was made up of atoms. All atoms of the same element are identical and have the same masses. Atoms of different element vary in size, mass, and chemical behavior. Chemical compounds are made up of at least 2 atoms of different elements. The resulting particle is called a molecule. In a chemical reaction, atoms are rearranged, separated, or recombined to form new compounds, but no atom is created or destroyed. And the timestamp that we have in between is the Louisiana Purchase in 1803. Next up in 1811, we have a Vito Avogadro that said equal volumes of gas contains equal numbers of molecules. So you can see here there's equal numbers of molecules in these different gases, but they're the same size. I think I tried to make them the same size. The time event that happens between this scientist and this scientist's contribution to the atomic theory is the Civil War, which was from 1861 to 1865. Up next in 1869 is Dmitry Mendeleev, who said that elements show grouping by similar characteristics when they are organized by ascending atomic mass. So here we have hydrogen and sodium, which are in the same column, and let me make sure I do that right. They both blow up when in water, like that. So this one's going to as well. I did not think that was going to blow up that much, but they both blew up. You get the point. I'm trying, okay? Anyways, in 1869 was the creation of Scotland's second oldest soccer team, which is pretty cool, because that was a while ago. Mary Curie, the only woman on this list, said in 1898, the powerful rays of energy that polonium and radium give off were actually particles from atoms disintegrating inside of the elements. So I didn't know how to represent that, so I put this, which I guess is supposed to be radium, and that's radiation, because that's basically the waves that they're talking about. Okay, you build it. See what you would do. What would you do? So our next time event is the Spanish and American War from 1899 to 1902. And this war started when the USS Maine was blown up, so why not? It should work. Please. Yay! Okay, it worked. You get the point. Up next is Max Planck in 1900, and what he said is every physical body can emit and absorb energy in distinct amounts, and the smaller the unit of energy that is absorbed or released in the form of electromagnetic radiation is known as quantum. I didn't do that. I had 2 guys. One said I emit and absorb energy, and this one says I do too. What do you want me to do? I know I'm complaining, and I could have easily done something else, but I committed on this way too late, and I had no clue what to do. All right, we're halfway done now. But up next, we have the birth year of Louis Armstrong, 1901. I made a trumpet because I think he plays the trumpet. Off the top of my head, I think he plays the trumpet. I'm gonna look that up just to make sure I don't look stupid. Yep, he plays the trumpet. I was right. All right, in 1904, J.J. Thomson discovered the electron. He hooked up a cathode ray tube to a battery with two metal plates inside of it, with one having a hole in it, and the beam on the inside was bended the opposite way that the magnet was facing. Therefore, there must have been something in the atom that had a negative charge. That's where he created the, I guess, idea of the electron. And in 1904 was the first underground subway system in New York City. And I just made this. I know it looks like a lump of crap. I already know I'm gonna butcher this name, but in 1904, Hantaro Nagoka, I think. I don't know. He theorized that atoms have a positively charged center surrounded by a number of revolving electrons. So that's just kind of what I made here. Then in 1905, the first Nobel Prize was awarded, which is pretty cool. It looks like a giant penny, so I made a giant penny. That's supposed to be a guy. In 1910, we have Robert Millikan, who said that electrons have a discrete quantifiable charge. And he also created the formula to find the mass of an electron. So I have kind of like the scale representing the scale that was over there. It's just mini because I'm lazy. And also it's 9:22 and I have not finished recording this. I still have to edit it. Mr. Newman, I promise I worked on it over the weekend. A little. However, in 1911, the Supreme Court broke up the Standard Oil Company, and I tried to recreate their logo. That's what that is. If you're one, that's what that is. You can look it up. It looks close enough. I don't care. Up next, we have Ernest Rutherford. In 1911, discovered the nucleus. He interacted a radioactive source with a very thin sheet of gold, and not all of the radioactive particles went through. So there must have been something positive that they were bumping off of, because there's a lot of open space in an atom. So the fact that it was bouncing off kind of irregularly, not all the time, showed that there was just something floating around in there that was randomly just bumping into. Then in 1912, the Titanic sunk. You know how the back end stuck out of the water, and that's supposed to be a smokestack? That's smoke coming out. There's the iceberg. I don't have much room to work with here, so I did the best I can. Then in 1913, Niels Bohr said that electrons move around the nucleus, but only in prescribed orbits. So if the electron jumps to a lower energy orbit, the difference is sent out as radiation. So yeah, I have a little nucleus, I guess that's what this would be, and this is just the track that electrons will go around. Then also in 1913, Henry Ford developed the modern assembly line. So these are supposed to be Model Ts. I don't know. I just threw them together, and I think this took less than 30 seconds. And in 1914, Henry Moseley said that atomic numbers are the fundamental features that describe an element. So I have hydrogen and the 1 because that's its atomic number. Then in 1914 to 1918 was World War I. I think you can. These are trenches, and the cobwebs. I broke one on accident, that's okay. The cobwebs are supposed to be like barbed wire because they have those everywhere throughout like no man's land. I think that's what that's called, yeah. And yeah, there's another trench. In 1924, Louis de Broglie said that particles such as electrons, it could be anything really, could be determined not only as particles but also as waves for how they fluctuate. So I just kind of made like a wave shape with some stained glass because it worked. Then in 1924 was the Winter Olympics in, I'm gonna butcher this, Chamonix. Yeah, I don't know. So I built like a ski slope, and these are supposed to be flags, but they really do not look like flags. They look terrible. Again, I'm gonna butcher this, but Erwin Schrödinger in 1926 said that the behavior of electrons within the atom could be explained by treating them mathematically as matter waves. So I just wrote the words math. Then in 1926 was the creation of the world's first fuel-powered rocket. This is supposed to be like a gas can, that's supposed to be like gas, and it's going on, this is supposed to be the engine or rocket. Yeah, you get it. And there's fire. Then in 1927, Werner Heisenberg discovered the uncertainty principle, which states that particles' position and momentum cannot be known exactly at the same time. So you don't know where, you can know where they are, but you don't know the momentum in which they're moving. You can know the momentum in which they're moving, but you can't know where they are. Basic. Then in 1929 to 1939 was the Great Depression. This is supposed to be a money bill, and that's supposed to be like the Ghostbusters thing, and I made it wrong and it's not centered, but it's okay. And this is the last one. James Chadwick in 1932 said that atoms not only consisted of protons and electrons, but also neutrons in the nucleus. Completed atom right there. Electrons, the blue things in there. Neutrons, the purple things, protons. I don't know. I made an atom. That's what that is. This took really long to make. Doesn't look like it, but laying all the red and then the walls. I think I started this at 4 and I'm just now getting done recording it at 9:33. I'm gonna post this on YouTube too. I don't think anyone's gonna care to watch it, but it's gonna be there. So yeah, that's that. Just I'm done.